Welcome to Data Brew by Databricks with Denny and Brooke. This series allows us to explore various topics in the data and AI community. And whether we're talking about data engineering or data science, we'll interview subject matter experts to dive deeper into these topics while we're enjoying our morning brew. My name is Denny Lee. I'm a principal developer advocate at Databricks and one half of Data Brew.
And hello, my name is Brooke Wenig, director of our machine learning practice at Databricks and the other half of Data Brew. And today I'm thrilled to introduce Dipendra Kumar, staff research scientist at Databricks, as well as Alnur Ali, SWE at Databricks. And today we're really going to focus on enterprise AI and how you can better be approaching these tasks. And so would love to kick it off with, given your experience in academia, how do enterprise use cases differ from academia? And perhaps Dipendra, you could start with this one.
Thanks, Brooke, and yeah, nice to be here. So I would say the enterprise use cases differ from academia in a couple of ways. In one case is that the enterprise users typically tend to have much higher expectation of the AI system than the academia. So for example, like you are given a problem, and if a LLM can zero shot solve it and get like maybe 80% accuracy, that's really impressive. But in academia, in enterprise, like you may need like 99.999% accuracy before it's really useful. Otherwise, it's really frustrating for people, who are paying a lot of money to use these applications, which still have a pretty high error rate. An analogous example would be like, driverless cars. So we know that driverless cars are quite good, like impressively good, but for them to be like truly used in real world everywhere, they have to have like really, really high accuracy because, like killing people with like 0.1% probability is just like not good enough. We need like really, really low error rate. And that's one of the high precision requirement is one way in which enterprise use cases differ quite a bit. Another one is that the enterprise examples tend to be a lot more messier than academia problem. In academic problems, like you typically are studying like one aspect of the problem. So let's say you care about like, well, I'm going to look at LLMs and see if they can process really long documents. So you're studying that challenge, but the other challenges have been somewhat controlled or simplified. But in enterprise use case, you will see like examples with all sort of nuances, which may not even be very easy to describe. You may have examples with missing data, like you may have like spelling mistakes and typos. You may have person who asked a question and then went back and essentially kind of want to restart and ask another question. So you might see like all kind of complications. The queries might be much more complex than what you would see in academic problems. So yeah, so those are the two ways in which enterprise examples differ.
And Alnur, given that you work on the engineering side, how do you combine the best of both approaches? How do you combine academia with enterprise?
Yeah, I think in general, just to plus one, everything Dipendra said, I do think maybe the starting point is, yeah, I think one of the problems with academia is that there's a lot of simplifying assumptions that are made, right? There's good things and there's maybe not as good things about academia, but one of the things we could do better at is we make a lot of simplifying assumptions. So for example, as Dipendra said, when someone asks, like, say, two questions of some product, in academia, we would assume generally that these two questions have nothing to do with each other. That's a simplifying assumption. It makes our lives easier, but that's just never true in practice. So I guess where I'm going with all this is simplifying assumptions are not a bad starting point. I think the kind of tools and techniques we have in academia generally are a pretty reasonable starting point. But from there, it's a lot about rolling back or addressing some of the kind of considerations that arise in the real world that academia doesn't even usually touch, right? So I think generally, an approach that works well is look to academia, but start as simple as possible. That might mean going back like a decade, 2 decades, 3 or further, and just start with the simplest possible approach, get rolling with that, and then think really hard about how to make that approach actually work in the application at hand. So that's kind of vague advice, and I'm happy to be a little bit more specific if that would be helpful. But
Actually, let's dive right into that, in fact. So, for example, you talk about going vague before you go more precise. Let me go even more fundamental here, which is, when I run my AI system, right, to get it to work in the real world, that is, right? Can't I just like make an API call? Can't I just go ahead and just say, hey, here's my information, make an API call, and boom, magically everything works. And you're of course going to tell me how wrong that is, but like describe, clarify that context.
Yeah, so let's instantiate this whole thing a little bit.
Please.
And let's take as a running example, well, you said enterprise data. So I think without necessarily putting our fingers on a particular product, the general idea of building a product that lets enterprise users ask questions of their data and return answers. Okay, that seems like a pretty reasonable product. So let's think about what it would take to build that. Okay, on option behind door number one is user types a question, we phone some API somewhere, we get an answer, and then like life is amazing. Why would we need to do anything else? Okay,
So we're done, right?
so
No.
apparently, right? We just cut the podcast now, or we're good to go.
Okay, we're finished. Thank you, everybody.
All right, thanks for tuning in. Yeah, so if we step down into the details a little bit, what's going on? Okay, so in order for this API call, if we're insisting on using one, to even have a sense of the data that it's supposed to answer questions of in the first place, okay, so we probably need to transmit some part of that data to the API, and maybe it's backed by an LLM, the API call. So the LLM needs to see some of that data. Okay, how much? What parts of the data? Do you take all of it? That's just obviously not going to work. Do you take some of it? Which parts? Do you kind of compress things down more than you need to? Because even nowadays, if LLMs can ingest a lot of content or context, that's kind of the word that we use, it doesn't mean that they can make sense of all of it. Okay, fine. So that in and of itself, I mean, that just took 15 seconds, but that is a ton of actually technical detail that goes into making that work. And then on the other end, say, fine, everything's great. We send a request to an API, we get a call back. Now what, right? I mean, even if you take the limiting point of view, which is that LLMs will be and are as good as humans. I mean, humans make mistakes, right? I screw things up all the time. You have to account for that. So what happens on the backside, right? So after you get the content back from the API call. Anyway, hopefully that illustrates some of the issues. But Dipendra, yeah, I don't know.
Yeah, I can add, but I think I agree with what Alnur said. One thing I would say is that in academia, like the focus again is like on studying like one specific problem, and that's really important. We have gained a lot of useful insights. Like, as I mentioned earlier, like, let's say I'm interested in studying how good do LLMs do as I give them longer and longer documents to process. So I'm like studying this like length phenomena over there. So I want to simplify other aspects of the problem, not because I don't care about them, but because in this particular study, I only want to investigate this one single factor. And this allows us to like, get insights about, how does a performance scale as, LLMs are working on bigger and bigger documents. But, in enterprise use case, you're not really like, looking for these kind of trends, but we really just want to solve the problems that our customers come with. And so that's one way in which you can do, work on academic problems. And, sometimes we do that too, like, study a problem in isolation to kind of get insights. But then, we have to use those insights to then solve like our customer's problem where, all sort of challenges and nuances exist simultaneously.
Yeah, and I think that's a very important point that you just raised, Dipendra, about use cases that actually make money or help driving the enterprise, not just things that are cool. It's like, I don't know how many of us actually need to like generate rap style presentations, but it is a cool use case.
Right.
So I know that you two work very closely together. Dipendra, you're more on the research side. Alnur, you're bridging the divide between theory and practice. Dipendra, I was hoping we could chat a bit more about this QuickFix work that you're doing. And perhaps you could start off with explaining what is QuickFix.
Right. So QuickFix is an AI product that we have in the Databricks notebooks. So I'm not sure about you, but, I make a lot of mistakes when I'm coding. I might forget like, a quotation and stuff. Like some of these things have been removed with Copilots, but, there's still like some typos and stuff. So what QuickFix does is that anytime you run a cell in the notebook and there is an error, then the QuickFix will propose a fix. Sometimes these errors are super simple, like a person just forgot like a closing parenthesis. Sometimes they're a lot more complex. Maybe they are using a different length function than the one that exists in the language. It happens if you're like constantly like hopping between programmed languages. You might just not have like the right one under your fingertips. So the QuickFix will propose a fix for buggy code. And so that's the idea. And you can imagine as building on what Alnur said, that you can just give it to a GPT-4 agent or a Llama agent or any one of these popular LLMs, and you can go quite far with just that. Like, it's impressive that you can get like even like 50, 60 or some non-trivial performance, but they're not perfect. And there's a big leg room to kind of go before we can, like be like essentially declared like victory. And so our work has been on how can we improve upon these base agents to take better actions. And of course, there are two ways in which we can address these things. One is this more agentic way of doing it, where, oh, how do we do better prompting of the agents? Oh, if the agent makes mistakes, can we detect it and then ask it in a different way? Or can I break the problem into smaller components and then solve them? So there's a lot of impressive work that is happening in this space. Like anytime you hear words like prompt engineering, retrieval, RAGs, that all comes under this umbrella. The other one is that can I just improve the LLM directly by fine tuning it or like doing some clever post training, such that the my LLM is much more focused and accurate on this task. And that's also something we are looking at. And or all I can say in this meeting is that we have pretty impressive gains over some of the base models that we have tried, and we'll be talking about it at some in some format in the future.
And so I think this ties in very nicely to a paper that you had co-authored about user edits. Could you talk about how user edits come into play with QuickFix?
Perfect. So the user edits idea is that if you think about how people actually interact with an LLM in many applications, it comes down to the following flowchart. The user is working on some kind of a platform. Let's say they're writing an essay or composing an email. At some point, they would query an LLM. Either they may, query it themselves, or maybe the application triggers it behind the scene. And then an LLM agent will generate a response. And the user may look at it and they're like, oh, this is quite good, but not, perfect. And so I'm just going to edit it. And they're editing it because they care about, the final thing. It's not because, we are paying them to edit. They do it for their own purpose. And if we can use these edits to then learn about the user's preferences. For example, we may understand that, oh, they actually spell everything in a British format. So we should, like, in the future, suggest things to them in British English than American English. Or we may suggest that they prefer certain things in bullet point format rather than in small condensed paragraphs. So we can learn a lot about these kind of preferences. But the broader idea being is that the user edits are a very common kind of feedback mechanism that exists, and we can use them to improve our LLM agents. Now, tying it back to the QuickFix Brooke, I would say that in QuickFix example, what sometimes can happen is that the user will write a code, run the code, and then there is an error message. And maybe, 30 seconds later, they fix the bug and then run the code, and this time it works. They have just edited their code. And so you can learn about what kind of errors this user commonly runs into, and how to fix those errors to make them go away. So suddenly you have this edit data, and of course I'm assuming here we have the legal and the compliance permission from the user side to of course use these edits. But if we have that, then user edits provide a natural mechanism for us to improve the LLM agents.
This is really cool. So then, I guess is from that perspective, Alnur, following up exactly on this context of quick fix and user edits, are those really the biggest challenges for building these, LM or agentic projects, or are there other aspects that are sort of underneath the covers per se, as the engineer behind all this?
Yeah, no, I mean, I think all of that's super critical. Maybe a few things I could add, which I think apply to at least a handful, if not most, enterprise-facing products that kind of maybe where you want to bring techniques over from research. So I guess one of the challenges that you hit when you actually want to make this stuff real is scale, right? So that kind of touches on the thing we were talking about, say, 5 minutes ago about, okay, like you pull data into the context window, you throw it to an LLM, how much, right? Like, do you compress it down or not? Okay, fine. That's one form of scale. The other is lots of requests, right? Like ideally you build a product that is actually successful. That means a lot of people are using it. Just kind of, that is an engineering problem. And just kind of getting your hands around that is another thing that we don't really commonly think about when we're building these products or building these, deploying these applications in research. Another issue that we hit when trying to make things real is security, right? So uh, commonly at the end of the day, these kind of agentic LLM-driven systems are hitting data in one way or the other, right? It could be user code, as in the QuickFix example. It could be just like literally raw user data tables. It could be something else. Um, can everyone have access to all of that? Is that okay, actually, right? Can an LLM actually, to make even the point a little bit stronger, what if we show the LLM data for customer A and it somehow regurgitates that data in some way, shape, or form to customer B? That's like obviously not, it's not going to fly, but I don't even think we necessarily, I mean, I don't want to say academia doesn't think about all these, but it is the vast, vast minority of work, and that's published in academia, is to think about these types of challenges, which are, it's like step zero when you are trying to get something out into production. You cannot risk something like that because it's reputationally bad. It's bad for customers. So on and so forth. Maybe I'll just make one more point before I can pause, because I don't know, three things are good. The third is, I think this is a repackaging of something Dipendra said, but robustness, right? So just because, in academia, what we like, the way we often have, the way we evaluate things and have for like decades is, you build some machine learning model. It could be an LLM. It could be something that we now call old school, like, I don't know, logistic regression, linear regression, something like that. And we throw a test case at it, one test case, and we say, how did you do? Okay, you did kind of okay, fine. Move on to the next one. How did you do? You did a little bit better. Okay, fine. And then we just we average all those scores. Okay, there's a few things going on here. One is we're assuming these test cases are all kind of similar. Two is we're assuming there's no interrelationship or serial dependencies between these test cases. Like, sorry, that actually just neither of those are true in practice, right? The data that you kind of tune your model on, be it an LLM or something else offline, it's never going to be what you see online. There actually is a name for that, and it's called distribution shift. And that problem has seen a ton of interest in machine learning over the last few years, which is no surprise because these things are making their way in a serious way into production, right? So people are like, okay, like we need to think about that. The other problem has a name too, which we can get into if you want, but it is also just like a fundamental problem that you hit in the real world where, yeah, I might, the next interaction a user has with a data-driven system almost certainly has something to do with the preceding one, or perhaps the one before that, and kind of grappling with these short or long range dependencies is kind of critical. So I think those are maybe three things off the top of my head that are important to come to terms with.
Okay, well, so just to follow that, so you described a lot about scale, about security, and about robustness. That's great. Understand that context, but I guess what a lot of folks will just simply say, why can't I just use an open AI? Why can't I just use Anthropic or Cohere? Just to go do that? Why can't I just like let them take care of all the security or robustness or scalability behind it?
Yeah, two answers to that. Number one is, so think about how these models are trained, right? I mean, there's no question, just, table stakes is they are amazing. They are, these models collectively are just, I think, pushing the field forward. But if we think about how they're trained, they're typically trained using public data, right? They're not trained using your data.
Got it.
You're a
Right.
customer who wants to do who knows what. I mean, I was telling you I was at a cookie store the other day. Okay, how are my cookie sales doing, right? There's no way OpenAI has access to the cookie data, right, for this cookie store. So that is going to totally change the complexion of the model, right? If it was ever to look at cookie data. It's kind of a funny thing to say, but in any case, so I think that is one thing where I'm not 100% sure how that gap really ever gets bridged in a meaningful way. So what you do need a solution that pays attention to that, treats that data with care in a secure kind of proper way. The other thing is, this kind of rewinds to maybe one of the first things we said, which is it's one thing to build. I don't know. Let's just even take a chatbot, right? To build and fine tune an LLM or build just one LLM in isolation, but to get these things to actually typically work in practice, these are parts of a product. They're parts of a user experience, right? It's not sufficient typically to just be like, LLM answered this question. Okay, I get the response and I throw it back to the user. That's just not going to fly, right? Like I think there's a lot of, window dressing is doing it a disservice, but there's a lot of post-processing that applies on top of the LLM that is almost always bespoke for the application at hand. And it kind of doesn't maybe necessarily even parse to me to say, let's let a kind of off-the-shelf provider think about all those different use cases. Like that's kind of crazy and probably not what they're there for. They're there for more of the horizontal play. Yeah. Anyway.
So would you all say that there's a shift from like this thinking of like one model to rule them all to many smaller, more bespoke models?
I can answer that, Brooke. So I think so one model is going to be a lot more expensive. Like think about what information is contained in these like general purpose models like Llama and GPT and Claude. Like they have information about a bunch of video games. They have information about all the countries, their temperature, history of the countries, Middle Ages, like fantasy world, like like some other kind of like random information, translations, different languages. But what happens in enterprise use case is that you have customers who just care about one thing, which is given a document, extract the names of every person in this contract and how much revenue was made. They don't care about like, Norse mythology or like, the temperature at which the olives are best for like, plucking or whatever. So you have like this very specific use cases, but there's a demand for very high precision on these specific use cases. And so you can use a general purpose model. What you will typically observe in my experience is that you will get a very surprisingly very good accuracy, but not perfect accuracy. There will still be a lot of leg room. So I'm just going to make up some numbers, but let's say you want like 99.9% accuracy for it to be like in an automatable stage, in the sense that you can just let it run without a human constantly monitoring the output. You may get there like 80% with these models, but there's still like this like last 20% difference. And I think there's a saying that 90% of the work is in the last 10%. So there is this like, this gap that you still need to do. It's very surprising that, these general purpose models, which have never looked at your problem, can get that. But that is not enough for enterprise customers at times to just like fully, like let it run on its own. And so what we have found useful is that you can train like smaller LLMs, which are first of all more cost effective and on these specific tasks, and get them to be much more accurate than these general purpose models. And that's some of the directions that in Databricks and also some other places have been exploring. And I think this is going to be a lot more promising direction, simply because cost is something that, people care about a lot in enterprise, because you're going to be like making like many like queries to these models, and, big models are just more expensive.
I definitely like that new LLM Pareto principle. I definitely think it's more 90-10 than 80-20, exactly as you had said. I guess is it really just cost that's the concern? Like, what about latency? Like what are the trade-offs you get there?
Right. So a smaller model is just going to have like it will be faster to do inference, and so it would be much quicker. That said, like this advantage is a lot more hard to see, and you may not even observe it in the beginning, because when you have a single model, you can just have more replicas of it, or just like use your economy of scale principles to make it really good. And as opposed to have a single model which only handles a part of the problems. But eventually, as we have like fewer of these smaller models, so let me put it this way. So you can go one full extreme, which is that for every small difference of the every small change to the task, I'm going to train my own small language model for it. Right? That's the other extreme. That now you can, and this is how classic machine learning used to be. That you have a task and you train a machine learning model for it and you get some numbers. I think there's a nice middle ground in the middle, that let's say we see that 80% of our customers are always running into these 5 problems. And so I can now train an enterprise focused language model that can handle these 5 tasks very well. Right. So you are still in this kind of middle way where, you are using an LLM to do many tasks, but you're not like going per task. And so this still allows you to like have a single model that you can optimize really well, that you can, put it everywhere around the world. So your latency is low, and this is a smaller language model. And so it's still cheaper. So I think that's like a nice middle ground that some of us are aiming for. And I think that would be a big thing going forward in 2025.
So right now, one of the things that we've noticed is that this collaboration of research and engineering, right? And so it seems like you're plus oneing each other. Where in other words, there's tantamount agreement here. Now that can't be true. So I'm just curious, I'm not trying to start a war here. Don't worry, but I'm just curious, like where are the parts where you from a research and from an engineering perspective where you do agree, but then also the parts where you may not agree as much. I'm just curious, and I'll start with Dipendra, and then and not to give Alnur the last word, but that's the con. Yeah, I'm an engineer, so I figure I'll give the engineer the last word. So
So one, like, if I just put my researcher hat on, like, there are things that I wish that it just don't exist. Like, oh, so I just want all my data to be in a consistent format. So I don't have to worry about that. So I can just think about, cool research problems. And that's something you just don't see. You will see, for example, like, the data was being collected in one way, but then got changed and then got changed again. And then, it's being changed every week because, we don't really have a control over it. And so that's like one kind of that we run into. Another problem could be that like, I really wish we had this extra information, which would then make our life easier and this problem wouldn't exist. And no, we can't get that information for one of many reasons we can get into. So I would say those are the problems that like the researchers can ignore. And this is why I'm a big proponent of like researchers working closely with engineers, because you might solve a problem in isolation and it looks like mathematically beautiful. And you're like, oh, this is amazing. Pat on batch, write a good paper, get it accepted at a conference. But then you realize that you cannot apply that method because the kind of feedback you need just doesn't exist. Like nobody has it, right? And maybe to give an example, like there's a field of machine learning called reinforcement learning. The idea being that, you have an agent which gets a reward for doing things, and then you maximize the reward. And there's a lot of impressive algorithms and other stuff that has been built in this space. I worked in this space for many years. But the problem is that rewards almost never exist directly. So you almost always have to induce them from something else. And so that's kind of one misalignment that you may see in, where you build your research artifact with some assumption about the world, only to find that assumption is not satisfied. In some cases, you can solve it by having a missing step. So in case of reinforcement learning, people have figured that you can use preference data, which is a bit more natural, to then learn a reward model. But sometimes, that misalignment is true and you just have to start over again.
makes sense. How are you, Alnur? Like from your perspective, then.
Yeah, well, okay, disclaimer. I'm going to say I'll make 2 points, none of which apply to Dipendra or his group. They are fantastic. They are beyond reproach. No, seriously. I mean, they
So we're gonna
seriously
clip it from this point onwards. Got it. Okay,
yeah,
got it.
right. Yeah, let's let off the record. No, seriously, they are amazing, and I'm actually being serious. What I'm going to say, I actually do not have Dipendra and his team in mind. Just general observations, having been in the field for a while. So number one is, I guess the way I generally look at the interaction between product and research is as follows. If you think about the projects or investments you're going to make, you can write down a little matrix that trades risk against reward. Okay, so risk could be, the idea may or may not pan out. It could also be effort or something like that. Reward, maybe that's kind of obvious. And I think in general, the best use of research resources is not to focus on the low risk stuff. I think it's probably to focus on the medium or higher risk, and you would hope, therefore, medium and higher reward stuff. And I think sometimes a consequence of that is, I mean, if you think about, okay, so what happens when you're getting your PhD? You're pushing the state of the art, right? So, and you're building on the shoulders of giants. It's not really just a saying, it's actually true. And what does that usually mean? It usually means you end up developing something new, shiny, and fancy, right? And I think that's typically where the incentives lie. And I was guilty of that too. Like, I think I always wanted to do fancy, cool stuff, and I had two advisors in my career that just kind of beat that out of me, and they were like, "No, just always do the simplest thing." And I didn't like it then, but now I'm really grateful for it now. And I guess where I'm going with this is, in practice, it's almost always the simple things that are the ones that at least get you maybe 90%, if not 100% of the way there. And there can sometimes be a tension between, hey, cool, look at this new thing I pulled off of archive. Like, let's try that out versus why don't we do least squares regression from like hundreds of years ago? Because that could just be as fine. Right. So I think there's sometimes that tension and just kind of like that's a discussion, right? Like, I think it's a conversation that both sides need to have and kind of come together. That's one thing to watch out for. I guess a related thing is maybe goal alignment, right? So, uh, depending on where you are, research, I think this is less true nowadays, but research can be incentivized to write papers, not as much deploy product. Again, I think that's less true nowadays. And even still, I think for research teams that are trying to deploy products, maybe what I'm getting at is the closer you can actually be to the product roadmap and how the product team conceives of the product, not just being deployed in the next year, but the next 5 years, 10 years, the better, because that just means, as I said, research is typically working on higher risk, higher reward things. It's kind of important to get those initial steps right, because you're just going to be charting a trajectory that could be a little bit divergent from where the product team actually wants to head. So those are my two observations.
This is really cool. So, okay, just to wrap, we're almost wrapping this things up. So, this is a really good showcase of like why people should work with Databricks engineers and researchers, right? So, this is awesome. So, yeah, but I guess I'm asking, what's your I guess almost like 30-second pitch on explaining why is it great to work with y'all? I guess.
Alnur, do you want to go first?
Yeah, I can go for it. Well, I think number one, if you want to work on problems, I don't really mean to disparage academia. I spent a number of years in academia. I love academia, but if you want to work on problems that you can actually, maybe I wouldn't say really matter, but you can see a through line to them getting out in the real world and actually impacting people's lives, I think there's kind of no better place to do it. I think if you want to see things actually kind of make a difference and think about, I don't want to say left brain, right brain, but if you want to be creative and develop algorithms, but also think about some of these deployment questions and scalability and user experience, I think there's really no better place to do it. And maybe the third point I would make is Databricks in particular. I think the culture here is awesome. It kind of makes sense given who the founders are, that they come from an academic background. But to me, it is one of they do such a good job balancing inquisitiveness and these traits that we really like in academia with actually being practical and let's go and actually get things out and done. So I think to me, it's a great culture too.
Yeah, I mean, I think I agree with everything Alnur said. And I would say that has been my experience. So I joined Databricks earlier this year. And it's very easy to like make an impact at Databricks at scale. First of all, we have a lot of customers. And so if you make an AI product that is seen by your customer, you can make a lot of impact very quickly. And Databricks has this kind of very nice balance, as Alnur mentioned, of, we have founders who are coming from academia. So there's a lot of creativity, but that's not creativity for creativity's sake. That's creativity in service of, solving our customer's problem. And so you get this nice balancing where, you can still, we do a lot of creative research and, like many of us do write papers, but it's in pursuit of like making impact that is tangible in the real world. So I think that balance, it's very hard to achieve at other places. And so, if there are other researchers who like that, then I think Databricks is a very good place for them.
Awesome. I loved how harmonious your answers are. We did not achieve in getting you two to disagree about a topic. But
No,
I'm
I tried to think things up, but I still couldn't do it. Dang
It wasn't coordinated either. It wasn't coordinated.
So I guess just as a closing question for both of you, with all of these advancements within Gen AI, I know one of the concerns people have is, will programmers still have a job? Or will people still need to learn how to program? And so curious to get both of your takes on that.
So I would say, in the short run, I mean, nobody can predict 5 years from now, right? That's a very long window. But in the short run, I would say AI is more as a tool that you can use, a much more sophisticated and a much more powerful tools than like the ones that we had before. But it is still a tool that someone should use. So I would say like a programmer should think more like that. Oh, instead of me memorizing now all these APIs or having to constantly look them up on Stack Overflow, I can do much more high level thinking. So, my LLM can take care of like, more low level like coding and like, writing down like the exact format. And as a programmer, I can free my mind to like do like much more strategic thinking about, oh, how my files should be communicating, what should be the higher level structure of my code and program. And it just makes you much more productive. So maybe there comes a time where we just have to talk to an LLM agent or some other thing, and it just does everything for us. But right now, we are at a point where they're pretty good. But you still need a human to do like the strategic thinking. Like, what do you first of all even send to the LLM, right? Like, how do you even describe your problem? Right? There are many problems that are not easy to describe that you might just like, want to do it yourself. Or there might be problems where LLMs are still pretty noisy. So in the short run, with that disclaimer, like I would encourage programmers to still learn programming and use and think about LLMs as more as tools to enhance their productivity than like, oh, they're here to like take our jobs.
I totally would agree with that. I think LMs are here to stay. I think I do think it's probably going to be a better together kind of thing where they can be used. I think quite maybe profitably is not the right word, but as a tool that can make us more productive and deliver kind of reach higher results and things like that. I mean, I just think that even today, if you throw an LLM and maybe not the best example, but a simple arithmetic task, it's going to make a mistake most likely, right? Like I think these things can do amazing things, but there's still a ways to go. And I think there's still room for, as Dipendra said, people to be a little bit more in the driver's seat, especially when it comes to things about thinking about design, architecture, scale, things like that, which are not just can you pump out a simple Python function for me, but can you do a lot more than that, right? I do think, for some very, very mechanical tasks, okay, like maybe we will see some automation there, but hopefully, I think if, as a society, we work that through, we'll see people move up the value chain instead, right? So that's kind of how I think that's going to go.
And I really like how that wrapped it all together of humans can focus more on the strategy, robustness, scalability, letting LLMs do more of the low-level implementation. And I know a great tool and somebody that's working on it called QuickFix as part of the Databricks assistant, so you can all get started with getting some more productivity and efficiency gains.
Thanks, Brooke. Thanks, Denny.
Just want to say thank you both so much for joining us today on Data Brew and chatting about enterprise AI and all of the benefits of working on Databricks towards those goals.
Thanks.
Thank you for the opportunity.